Now we will use the integral test to determine whether series converge or diverge. So this first problem here, we see it's the series from n equals 1 to infinity of 1 over n squared. So for this, we need to evaluate the integral from 1 to infinity of 1 over x squared dx. To evaluate this integral, we observe that this is an improper integral. And so thus we have to replace the infinity with an n. And so we see that this is limit as n goes to infinity of 1 to n of 1 over x squared dx. And so if we compute this integral, we get an antiderivative of negative 1 over x, or from 1 to n. If we plug in our limits, we get that this is negative 1 over n plus 1 over 1, or its limit as n goes to infinity of 1 minus 1 over n. The 1 over n part approaches 0. And so we see that this is simply equal to 1. Since this improper integral is equal to 1, a finite number, it converges. And thus, our series, n equals 1 to infinity of 1 over n squared, converges by the integral test. If we look at the series n equals 1 to infinity, to use the integral test, we want to evaluate the integral from 1 to infinity of 1 over x dx. To evaluate this improper integral, once again we have to write this as a limit. And our antiderivative of 1 over x is ln of absolute value of x. And so if we plug in our limits of integration, we see that this is limit as n goes to infinity of ln of n minus ln of 1, or limit as n goes to infinity of ln of n. And this limit is equal to infinity, and so the integral diverges. And since this integral diverges, we get that this series from n equals 1 to infinity of 1 over n also diverges. And this is by the integral test.